We are given a disk. So let this be our disk. This be the center of the disk, and let this be diameter. So it is given that if the moment of inertia of the disk about this axis is I, what is the moment of inertia about an axis which passes through the rim and perpendicular to the plane of the disk? So let this be our axis. We need to find the moment of inertia about this axis. Okay. So we know that moment of inertia of the disk through the axis, through an axis passing through the center is m r square by 2. So let's call it as IC, which is moment of inertia of the disk through about an axis passing through its center. IC equals to m r square by 2, where r is the radius. So let's say where r is the radius. So by perpendicular axis theorem, we can draw two perpendicular lines. Because of symmetry, without loss of generality, we can consider this as also I, if this is I. So I plus I is equals to IC. This is perpendicular axis theorem. So I equals to IC by 2. This implies I equals to mr square by 4. Now let's consider. So let this be the center, and let this be the point on the rim of the disk through which an axis is going. So we need to find the moment of inertia about the axis going through this point. So if this is I, let's call it I say. Then IR, let this be IR. Then we know that IR equals to IC plus MD square, where D is the distance between these two points, these two axes. So I'm going to say axis. So we know D is equals to R. So AR is equals to IC plus MR square. IC equals to 2 times of I, and MR square equals to 4 times of I. So IR equals to 6 times of I. So moment of inertia of the uniform disk about an axis passing through the rim is 6 times I, where I is the moment of inertia passing through one of its diameter.